everyone. It's June 28th. We had some great pizza. Macaroni and mac and cheese on pizza. We need this type of innovation more often. Dude, this is so good. So good. And it's vegan. Right. Vegan pizzeria. Macaroni, mac and cheese on top of as toppings for pizza. I suppose if you're like a true pizza, like an Italian guy, I love pizza, you might think this is sacrilege, this is blasphemy. But we don't care. We used to like the Indian pizza. Wow, like tikka masala on top of pizza. Oh my god, this is what innovation is. We need to do more of this. And the pizza size is so big. When it came, we just started laughing. Like, wow. We had some giant portions last week, and this week we got giant portions again.
Did you already review it?
Oh, I haven't reviewed it. I should. All right, let's see what we have today. It's likely that I've done this before. Yep, I've done this before. Number of sequences that satisfy the given sum condition. I have a new rule now. I will think about 10 to 15 minutes. If I cannot get it, I'll just go straight read the hints. And I still cannot get it, I just go read the tutorial. I don't have time or energy anymore to spend like 1 hour, think, do trying, and then fail. So
you're doing it for an hour?
Oh yeah, like a car probably could last for more than an hour. I don't have that in me anymore. Alright, enjoy. You're given an array of integers and an integer target. Return the number of non-empty subsequences of nums such that the sum of the minimum and the maximum element on it is less or equal to target. Since the answer may be too large, return modulo. Alright, let's do that one more time. Return the number of subsequences, non-empty subsequences, such that the sum of the minimum and the maximum is less than or equal to target. Can we sort it? I think we can. Actually, I don't know. I don't know about that. I don't know about sorting though. Sum of the minimum and the maximum elements on it is less than or equal to target. So I have a target. Okay, let's just draw a little bit. Right, so we have the target is 9. So let's say if I want to include 3, right? If I want to include 3, then I try 3 by itself, and then we say 9 minus 3 is 6. I can pick 5, I can pick 6, right? 3, 5, 3, 6. Ooh, we can do 3, 5, 6 because it's okay. But this is sorted. That's the question, like, can we sort? Yes, I think we can. Actually, no, we cannot. Because if this is, let's say, 3, 7, 6, 5, like this. 3, 6, and 3, 5, these doesn't work. Okay, you actually see that the answer will be different. this one again, but we changed the order. In fact, we just changed one order. We put 7 earlier. So kind of just show you cannot just simply sort it. If you see this one, it's not 4. I just said it's not 4, but expect it's 4 again. What? How? Oh, it's subsequent, so you can ignore it. Oh, then you just sort. Hold on, let me think one more time. Why do you think the things in between will matter? It will not matter, right? Ah, I see. No, let's change to 6 and 5. This is what we can prove. This is not 4, right? This is not 4, because you cannot do 3, 5. What? Oh, it's because 3, 6, 5 still works. Because 3, 6 works. But the point is, if you do that, and then like you change the order, maybe it does not matter. Maybe it does not matter. Hold on, let me think about it one more time. So like you sorted it, and you can pick, right? After you sort, you can easily pick the minimum, the maximum to do, right? And then in reality, right, in reality, yeah, so like you say, okay, we can try 3 and 5, so you find 3 and 5. Yeah, you can always do the 2 numbers, right? You can always do the 2 numbers, that's fine. 3 and 5. And then you say 3 and 6, right? Then what you need to make sure, and you have 3, 5, 3, 6, but when you do 3, 6, everybody in between can also be included. Right? Everybody in between can also be included because they're smaller. But my question is, in reality, if there's nothing in between, if there's nothing in between, no, it's fine because I can always eliminate whatever is like too big or too small. So there's only 3, 5, 6 left. So it doesn't matter what position they are. So in that case, yes, you sorted it and you just do it, right? So you start from the smallest and then you go this. In fact, no, your binary search, because it's big, right? Your binary search, 9 minus 3 is 6. Your binary search, so you find this. Basically, any combination of stuff, including 3 and 6, they will all work, right? They will all work. So basically, what we say is we're including 3, and we have, and then this is the last one, right? So for any one in between, any combination in it, they will all work. How many are there? How many are there? So essentially what we're saying is any combination will work with 3, right? Could be 0. You take 0, so basically however many this is, let's call it n. So we can say n choose 0 will work, n choose 1 will work, n choose 2 will work, all the way to n choose n. Now you just need to sigma this whole thing together. What's the sigma of this? If I believe it correctly, I think the sigma is 2 to the n minus 1. Something like that. I'm not 100% sure. Alright, I'll just calculate. This is 1. This is 4. This is 8. this is 16, and this is 32. So I think it's 2 to the power of n. Right? This is 0, 1. No, this is 1. Ooh, hold a second. No, I think there's a 1, 1. You missed the 1, 1. So there's a 2 here. Right? The 1 is 1. Right? So this 2 to the power of n. So in this case, we here, so we have 2. So 2 to the power of 2, we do this. And I start with 5 is nothing. So the answer is 4. Right? So next one, 3, 3, 6, 8. We do 3, you're going to do 6. So we have 2. So 2 to the power of 2. We do 3, we have 6. So it's 1 plus 2 to the power of 1. And that's it. So this answer is 6. Right? Last one, 2, 3, 3, 4, 6, 7. Target is 12. So for 2, can go all the way to 1, 2, 3, 4, 5. So 2 to the power of 5. Plus 3 is going to be, again, the last one. So 2 to the power of 4. 2 to the power of 3. 2 to the power of 2. That's it. So the answer is... Oh, actually, you have it by itself. 6. Yeah. You have 2 to the power of 0, right? So the answer is 32. This is 16, 8, 4, 1. What is that? 20, 29, 61. 61. Right? Yeah. So let's do it. We have a solution. Let's implement it. Sort nums, right? Then go from left to right for each number, for each element. Check which position, check which element, right, when added to, find the largest, right? Find the largest element such that their sum is not larger than target. And count the number of elements in between. Then the number of subsequences that satisfy the requirement and also start with the initial, the element is 2 to the power of n, where n is the number of elements in between. That's it. So call it log n. But in fact, I don't think we need to binary search it. I think 2 pointers can do. So we can save ourselves the hassle of binary search. So we'll have res actually let's do long. And alright, we sort it. say while I plus nums j. Oh. Target j plus plus. Right, j plus plus. So j come out. When you say res, we also have a mod. Nine. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh. Okay. Equal to res plus something. So it's going to be j minus I, right? 0, 1, 2. No, j minus I minus 1. Because j is pointing at the impossible position. And I don't include the first one because it should be the number in between. So it's going to be, yeah, so we're going to say 1 left shift j minus I minus 1. Right? And how do you make sure that this is a that could be a huge, right? That could be huge. We need to use power. We need to use power. Power with oh shoot. Base power, right? Base power and mod. Ugh. What's that? I think it's power larger than 0, right? If power is even and odd, then say res or times equal to b. Oh, okay, equal to res times b mod m. And then res equal to res times res mod m and p divided by equal to 2. Or we can say let's shift 1. Fancier. And then I'll return res. Not 100% sure, but I think it should be right. To the power of I'm not sure. What if like 2 to the power of 2? 2 to the power of 2. Yeah, it doesn't feel right. Maybe I should start with b base. 2 to the power of 2. Then I'll do this. 2 divided by 2, so p will equal to 1. Coming here. I forgot how to do that. C++ modulo power. Let's see. It is right. Oh, my bad. This is base. Base equal to base times base, and then your result just times base. When you have the result times base. This is right. Is you? Oh yeah, you just power in the base, right? Okay. This is right now. Okay, now we can do it. So rest plus equal to, what's this gonna be? Power base, and power. Power should be j minus I minus 1. What if p is 0? That's fine, right? And mod is going to be mod. And we'll do this, mod. Right? Actually, I don't think so, because as you go, it's actually now like, if I say this one could be this, right? So it should be on the right hand side, going down, right? And then you stop here. Then you go, if it's good, you should stop. I think this is actually very wrong. This should be num star size minus 1, right? And this is smaller. No, this is larger than target. Now we just do this. Right, j is larger equal to I, and this is larger than target. I move, boom. It comes out, right? Now we say if nums I plus nums j is smaller or equal to target. Right? If it's smaller than the target, then we do j minus I, the mod. This is fine. And here we have to say and j is larger equal to I. Right? So, but if j is smaller than I, then we'll get out. Then we'll return rest. Because the first thing that you can find, and as I move forward, right? As I move forward, then if it's still smaller or equal to, then we do it. If it's not, the j needs to shrink, right? And then at a point that they're equal, which is fine. So I have this example where we're stopping here, and 4, yeah, it's gonna be this, and now it is 6. It's too big. It's too big. Too big, and j move. Then it's smaller equal to, then we get out, right? And then blah blah blah. It's good. And then I move forward, then I become bigger than j. It looks good. It looks good. Let's try. I think it has to be long. So we do long, everything is long. Okay, maybe we should do everything is long. Yeah, let's do everything is long. Nope, still not right. Okay, let's see. The first one is this, j is here, j larger equal to this, and then the sum is larger than j minus minus, and then it's larger than, no, it's equal, jump out. If 3 plus 6 is good, and then with 2 minus this is 2, so 2 to the power of 2 should be 4. Why would you output? Right? Why would you output a wrong number? Left shift. I think it should be right shift. This right shift is divided by 2. Ugh. Alright, let's just divide by 2. Equal to 2. Alright, so now we got too much. So we got a 4. Right? Oh, it is done. And then, so I here, j is here. So now I come to 5. So I go to 5. The number is 5. And then we say this is larger than target. Yes, j minus minus. Right? And then, ooh, j is larger equal to I. Yeah, we have to do that. There we go. I think this one will work. This one will work. Okay, let's see. Submission in the past. Pretty decent. Power. Yeah, so it's the same thing. Alright, that'll be it. Nothing too much to say. I'll see you guys tomorrow.